Today, I want to prove that the formula for the sum of n positive integers is n times n plus 1 over 2. So let's prove that. So to start off, what we want to do is we're going to do this through mathematical induction. Now, what does that mean? We need to show that p. Now, p in this case, right, p is a property. Our property is this, right? So p to the 1 is true. So before we even begin, we can just take a look at this, right, and just plug in n. So we can say that this is 1, right? 1 equals 1 times 1 plus 1 over 2, right? Which just equals 2 over 2, which equals 1, right? So before we really even begin, we can just state that that is true, right? And then off that, what we want to also state is whenever p to some number k is true, p to the k plus 1 is true. Now, why do we need to show that? Well, if we have some p to the k, so we have p to the 2, right? That means p to the 3 is also true. If p to the 3 is true, p to the 4 is true, and so on. All right, so how should we start this? Well, let's assume n equals k, okay? So now what do we want to do? Well, let's just take our n values and let's plug in a k instead. So we get 1 plus ... plus, now instead of n we have k, equals k to the n plus 1, or sorry, k to the times k plus 1 over 2. All right, so that's what we have here. Now, what do we want to do? Well, we want to show that k plus 1 is true, all right? So on this side, what we want to do is we want to change this to 1 plus ... plus k plus, now we have k plus 1, all right? And then we're going to say that this equals, so wherever you see on this side, now wherever you see a k, what we're going to do is we're going to substitute in k plus 1 for k. And if we do that, and then this is in fact equal to that when we substitute in k plus 1 in for k, then it will in fact be true. So we get k plus 1, right? And then, so instead, so we have k plus 1 plus 1, right? Because we have this plus 1, so we can change that to k plus 2, right? And this is this whole thing over 2, okay? So now what do we want to do? As I said before, we want to show that this does in fact equal that. Well, before, we just showed that this, right, is in fact equal to that. All right, and we know that because we are assuming n equals k, right? So if n equals this whole thing, then k is this whole thing as well, right? So then we can say that this is in fact also k plus 1, right, over 2, and then we have this plus k plus 1, right? And then what do we want to do? Well, we can change this to k, actually, this is not k plus, this is multiplication, plus k times, so we can change this whole thing to k squared plus k over 2 plus k plus 1, right? So then, what can we do? Well, remember, if we want to take this and we want to put it over the 2 as the denominator, when we do that, to keep it equal to the same thing, we need to multiply them by 2, right? Because we're multiplying them by 2 and we're dividing them by 2. If you do that, it still stays the same. So we have k squared plus k plus, now we have 2k plus, and then 2, right? So then what do we want to do? Well, we can change over this whole thing over 2. Then we can change this to k squared plus 3k plus 2, right, over 2. And then what can we do? Well, we want to factor this. Now, to factor it, let's just remember, what multiplies to 2 and adds to 3? Well, 2 and 1, right? So then we can factor this whole thing as k plus 1 times k plus 2 over 2. So now that we have shown that when we substitute in k plus 1 over here and we add k plus 1 over here, that they are in fact still equal to each other, then we have shown that this formula is in fact true. Thank you so much for watching my video. Let me know if I said anything wrong or if you have anything additional to add. Have a great day.